Welcome to the session of visualization where we're going to learn how to visualize the data using Matplotlib library. But guys, there are a few prerequisites. So in case if you have no idea in Python or NumPy and Pandas, please make sure you learn that first and then you come to this particular session. So there are a few things that we need, that is NumPy Pandas library obviously, and we need this library called Matplotlib. So this library is required for the visualization purpose, and we're going to use this PLT term for that. All right. Now, before we start with the visualization, let me just tell you what is the importance of visualization. So, what we are learning, guys, we are learning how to visualize the data, right? Basically, how to make various plots like a line plot or a bar graph or maybe a pie chart, something like that. Why it is important? Because if you're doing an analysis on any data set, whatever your observation is, you want to showcase that observation to the client or to the boss, right? Now, instead of writing paragraphs or something, it would be a good option to show them the graphs or show them the visual data, because visual data are more interesting and more easy to understand, and it obviously makes a great impact on your presentation. Perfect, guys, let's move on with the first plot. That is the most simple plot, which is line plot. All right. So for that, what we have done is initially I have created two lists, X and Y. You can see over here, right? But make sure both the lists have same number of values. So here we have total six values, and in this list also we have total six values. All right. Now to make a line plot, it's very simple. You just have to use a PLT term, PLT dot, and you have to call the plot function where you need to pass the X and Y. There it is. So there you see a simple line plot. If you have any difficulty in understanding the plot, let me give you a very basic understanding of this. So, so guys, basically the first line that you see, right? The first coordinate that you see is 1 and 11, and the second coordinate that you see is 3 and 14, right? So your 1 and 11 is somewhere over here. On the x-axis, you have 1, and on the y-axis, you have 11. Similarly, second coordinate is 3 and 14, that is somewhere over here. So this is on the x-axis we have 3 and on the y-axis we have 14, right? So between both the points, basically it draws a line, it draws a straight line. That's how line plot works. Similarly, second line is from this coordinate to the next coordinate, and this goes on and creates a complete line plot. So I hope, guys, this is very simple and you have already understood what exactly it is. Moving on to some of the other variants of line plots, or some of the other properties or attributes that we're gonna include in line plots. Okay. Now the next is you can see I have plotted x and y, but you can see there's a line which also comes over here. So you can get rid of this line. You can just say plt dot and call this show function. So you can see that line is gone and you just have the simple line plot over here. You can actually right click and save this image and put it in your presentation. Okay. So as simple as that, you just plot it over here, save this image and put wherever you want, your presentation or wherever you want, right? Simple, just right click and save image. Okay. Now a different example. So you can see I have and list called x again, which is np.arrange that goes from 0 to 10 in a step size of 0.1. So going starting from 0 going till 10 in a step size of 0.1, and y is nothing but the sign value of x. Whatever values are there in x, y is the sign of that. That means let me just clearly print and show you. So this is the value of x that goes from 0 to 9.9. That means in a step size of 0.1. And let me print y as well. Y is nothing but the sign value of x. So sine 0 is 0 and sine 9.9 is minus 0.45 something. All right. But that's not important. That's not important. What is important over here is how does this plot looks like. So let me plot this plt dot plot where we pass x comma y and then plt dot show. All right, so you can see when we plot the x and y, it forms a sine wave, right? I can see over here. All right, so guys, this is just to show you an example, nothing else. But I hope you have understand. I hope you have understood how line plot works. All right. Now let's see some of the attributes. For example, there's something called fixed size, labels, and titles. I'll explain you one by one. Now we have to list area and price. So let's say area is something in square meters, and then price is something in lakhs. All right. So let's say this is the area of property and this is the price. So if I plot this plt dot plot area comma price, and then let me say plt dot show. So you can see there's a plot between the area and the price. But guys, if I show this plot to the client, all right, if I show this plot to the client, they won't be able to understand what exactly it is, right? Because there is no title, there's no labels. So that can be done through few functions. Let me show you. So let me show you a function to increase the size or play around with the size of the plot. That is plt dot figure. So whenever you're calling a figure function, you're actually initializing a figure. All right. And inside that, you can pass this argument called fixed size, where you can give the width and the height information. So let's say if I give 8 comma 6. So I guess 8 is the width. Yeah, 8 is the width and 6 is the height. So 8 pixels and 6 pixels like that. All right, 8 and 6. Okay. So that was about the figure size. That's how you can increase or decrease the figure size. Let me just decrease a little bit, make it let's say 6 comma 4. Yeah, this is fine. This is fine for me. And let's see how you add labels and titles. First of all, guys, I want to show you the title. So plt dot title. Let me add a title saying that area versus uh, price plot. Okay. So it shows area versus price plot. All right. So now you have a nice title using this function plt.title. Then let's mention again two more function, that is plt.xlabel. So whatever you want to mention on the x-axis, you can provide it over here. So basically on the x-axis we have area, and see similarly plt.ylabel, where we pass price, right? So guys, now you can see that on the x-axis we have this label area, and on the y-axis we have this label price. Yes. So this plot makes sense, right? Because it has the complete information. It's not just a simple line plot. You have the information in the plot as well. So remember, guys, these are some of the extra functions that we have learned. That is the figure function with the fixed size attribute. Sorry, the fixed size argument, and the x label, y label function, as well as the title function. But guys, remember one thing always, that always remember this: the show function should always be at the bottom, should always be at the last. All right. And on just top of that, you can do whatever you want to do, like title, label, and plot. So not just that, guys, always remember figure should always be the first function, and plot and show should always be the last function. And whatever you want to do in between just goes in between. All right, perfect. So that was about figure, fixed size, labels, and titles. Now let's talk about xlim, ylim. All right. So basically x limit and y limit, and these are used to define x and y range. So guys, in this plot, you can see that the area goes from 600 to 1400, and the price goes from 15 to 40. Now, if you wish, you can actually change this range, and that is done with the help of xlim and ylim. So for that purpose, what we'll do is we'll just copy this code, guys, paste it to this cell, and there let me add. I can add it anywhere. Let me add it over here. Let's say plt dot xlim, and this time currently it is, guys, from 600 to 1400. Let me change it to, let's say, 500 to 1500. Similarly, plt dot ylim, currently it is from 15 to 40. Let me just change it to 10 to 50, something like that. Okay, so now we can see, guys, this has changed. uh, it goes from, okay, I guess I've done a mistake over here. Let me pass it in a tuple. Okay, fine, guys, so basically it doesn't matter. I don't know why this is not included 1500. Oh, okay, okay. Instead of, I guess we already have a value which is 1500 over here, right? Okay, let me increase the range. Instead of 1500, let's make it 2000. Yeah, now it makes sense, correct? You can see it go the Y range goes from 10 to 50, and the X range goes from somewhere around 400 to 2000. So that's how we sorry, from 500 to 2000. Yeah, so that's how we have changed the range. All right. So guys, you can play around with xlim and ylim in case you want to change the range of x and y axis. Okay, perfect. Moving on to the next attribute, that is x ticks and y ticks. So when I say ticks, I'm talking about these values that you see over here: 600, 800, 1000, and 10, 15, 20. These values are known as the ticks. So let me copy this code again on top and paste it over here. And let's say now I don't want limits and all, so I'll just remove this code and let me put plt dot xticks, and we have to pass an argument called rotation. The rotation is 45, so it rotates by 45 degree. And similarly we have y ticks. We have rotation, and let's say let's rotate it by 90 degree or something. Let's make this plot. There's an attribute error. Sorry, there's a spelling mistake over here. Okay, let me run this now. So x ticks and y ticks. So you can see the x ticks rotated by 45 degrees and the y ticks rotated by 90 degrees. So this is actually very useful because sometimes instead of numbers, you might have some text over here, and sometimes these text overlap with each other, right? So instead of overlapping text, you can rotate them by 90 degrees. So your text will be vertical instead of horizontal. All right. Anyways, I hope you understand what is ticks, and inside that you pass the rotation value just to rotate the ticks. All right. So let me just quick do a recap. So simple functions: plot, show. These two functions are used just to plot the graph and then remove just to show the graph basically. Then we have the figure attribute, which should always be on the top. There you can pass an argument called fix size to increase or decrease the figure size, where the first one is the width and the second one is the height. And title for title, labels for labels, and then xlim and ylim for the range of x and y axis, xticks and yticks for rotating the ticks. All right. And lastly, we're gonna see how to do multiple plots. All right. So for that purpose, what we'll do is, let's say if we have an x which goes from 1 to 20. All right. Then we have, instead of having one y, we're gonna have two y. Y1 will be the square root of x. So whatever values are there in x, y1 is the square root of that, and y2 is the log of x. So whatever values you have in x, y2 is the log of that. All right. Okay. So now plt dot figure. Right now I'm not providing any fixed size. Okay. Then plt dot plot x comma y1. Then plt dot plot x comma y2. And at the end you say plt dot show. Guys, you can see, first of all, we are initializing the figure, and instead of one plot, we are doing two plots. One is the x with y1, and the other one is x with y2, and then we are calling the show function. If you wish, you can add the labels, text, whatever you want, but right now I'm just focusing on multiple plots. There it is. You can see the x is same, but on the y we have the log value and the square root value. That's why we have two different plots. Okay. But guys, which one is what? So the blue one is what, and this color is what, we have no idea, right? So what we can do, one thing is, whenever you're doing the plot, you can mention the color. So let's say for this, the color is blue, and the second one, let's say the color is yellow. So now you know that blue color is y1, so y1 is the square root, and y2 is log. So this blue is square root, and this is log. So that is one option, guys. You can provide the color. But apart from that, what you can do is you can also provide legends. All right. And I guess providing legends is really a good option. And how exactly you do it is you call plt.legend, and then there you pass labels. And in a list, you have to pass the labels. First one is square root, and the second one is log, right? So the first plot is y1, so first label is square root, and second is y2, that is log, so second label is log. Let's run this code, and now guys, you can see there's a nice legend over here that shows that the blue one is square root and the yellow one is log. So guys, I hope everything is clear till now about the line plots. Let me tell you something. Whatever attributes you have seen, these attributes will remain same throughout the journey. That is title, text, labels, limits. All these attributes will remain same, but for different plot, only this line will change. So plt.plot is for line plot. For a different type of plot, this will change, and the rest other attributes remain same. I hope this is clear to you. We are done with the line plots. Stay tuned for the next plot.